To talk more about the science behind the eclipse, we're joined now by Jonathan Bird. He joins us live via Skype from Vanderbilt University. He is a postdoctoral fellow in the Department of Physics and Astronomy. So basically, this is like the Super Bowl for you, Jonathan, if I'm not mistaken, this event. It was 1918 when we saw the last eclipse travel across the country. Well, when some people saw it. What forces of nature in the atmosphere actually have to be present to produce this phenomenon?
Actually, we live at a wonderful time in human history. The reason that we have a solar eclipse at all is because what we call the angular size, that is the size of the object on the sky, of both the moon and the sun, are exactly the same. So the moon is 400 times smaller than the sun, but it's also 400 times closer. And those two factors cancel out, and so you get this perfect alignment between the disk of the moon covering the disk of the sun.
How is this eclipse different than total eclipses in the past, or is it?
So in terms of space and astrophysics, it's actually not different at all. It's simply one object, the moon, passing in front of the sun. I think a major difference here is that it's had such a wide path across land. Most of the Earth's globe is covered with water, and so it's nice to have such a huge opportunity for people to come to the path of totality across the United States.
And Jonathan, will it look different regardless of where you are physically in the United States?
So where you are in the path of totality will actually change the duration of the eclipse very slightly. So if you move towards the edges, you actually have a smaller amount of time, but only by mere seconds. As you move away from the path of totality, you only will get a partial eclipse, and so you'll see as you move either south or north of that totality path, you will see less and less of the sun being obscured by the moon. But as for the event itself, as long as the cloud cover is negligible, as long as you can see the sun, that should look the same to each of us here on the planet.
Can you tell us how NASA is able to forecast and know that this is going to happen?
Yeah, so this is actually one of my favorite things. What this means is that we understand orbital mechanics, we understand gravity very, very well. So we're able to predict the orbits of obviously the Earth, the moon, and the sun, and predict this alignment. In the past, we can actually predict all of the eclipses that have happened in the past, and we can match those up with historical records quite nicely. And we can also predict thousands and thousands of years into the future, tens of thousands of years into the future, of what those eclipse times will be. Interestingly enough, we can't actually go to infinity. There are some small errors in our understanding of the orbit. They're slightly chaotic, is what we call them. And so many years in the future, millions of years in the future, we actually lose the ability to predict. But it means we understand what's happening in the solar system, at least in terms of gravity, very, very well.
Jonathan Bird, we certainly appreciate your time. Thank you so much. It's going to be a very exciting day, no matter where you are in the United States. Thank you for joining us live from Nashville.